Hi, everyone. Now that everybody has joined, I'm going to go ahead and get started. Today's webinar is why measuring page load is the wrong metric. Speaking today, we have Ed Salazar, Senior Sales Engineer here at New Relic, and as well, Clay Smith, who's a developer advocate. Before we get started, I wanted to go over a few housekeeping items. Today's webinar will be recorded, and you'll get an email to the recording tomorrow in your inbox. But while we have you here live, please make sure to ask any questions as we go along, and we'll be able to get to them at the end of the webinar. Of course, if we can't get to them by the end of the webinar, we will follow up with you individually via email, and we'll be happy to answer any specific questions that we don't get to live on the air. Moreover, there's room for feedback if you have any at the end of the presentation, and when you close the GoToWebinar panel, you will be able to give us that feedback and tell us how we did, as well as ways that we can improve in the future. So with that, I'll hand it over to Ed, and he'll get us started.
Perfect. Okay, so let's jump in here with, what is this really about, right? It's kind of an interesting topic, right? So why would I not want to measure page load? It seems a little odd. Okay, I'll bite. What are we really talking about today? And I think the big piece here is going to be from a customer experience focus, right? That's what we're really focused on. If we look at New Relic platform and what we're trying to accomplish with it, we're really talking about the end user experience, right? So from a browser and insights as our products, but mostly we're going to be talking about what is a better way for us to sort of measure perceived performance. So an alternative title for this webinar would be sort of measuring perceived performance. From an agenda, what we want to do is sort of scope out where we came from, show you how we can do better, and then put it all together with some of our insights dashboard. So how do we measure it today? What are we currently doing? Can we do that better? And why does this matter at all, right? What's the business impact of doing this the wrong way? What I'd like to do from there is some folks on are going to be already pretty technical and understand, yeah, we get it. The Onload event may not necessarily be the best. Show us how we do it better, right? So the demos will come in to be there to show you how to prove it for yourself. So I'm going to prove it on a few sites that this shouldn't be the number and what numbers we should use. And then after that, Clay's going to come in and show you specifically how to actually instrument these custom attributes that we're collecting, right? So how do I use that user timing API to set some marks? How do I measure my perceived load times, whether that's with a hero image or above the fold? We've heard a lot of these definitions thrown out. So I'll talk a little bit about what those definitions are and ways that other organizations are actually using them. And then finally, once we have already marked our page, right, simple process, where do we send it and how do we see it? So let's put it all together by sending it over into Insights, show you how we can do it in either a session trace in browser or in some dashboards with our, again, digital intelligence platform. We're going to be talking about your ability to view this data from all of your real end users, right? So as we begin, the first thing that comes up is like, wow, first slide, you're going to throw this crazy diagram at me. This is pretty much the way that we're measuring today, but I'll simplify it for you. I'll make this very easy. We're using what we call a navigation timing API. When I say we, I'm pretty much mean the performance industry, not necessarily just New Relic from a browser perspective. So the navigation timing API, I'm not going to sort of bag on it too much. I actually really like it. It's just one particular metric I might have a bit of an issue with. But let's think about it from like my homepage. Let's just think about your homepage, and let's say it takes 5 seconds to load, right? Whether that's good or whether that's bad, let's leave that out for right now. But I need to know what's going on that page, right? So what is it that's taking 5 seconds? That's why navigation timing API is so powerful, because I can split it up into a bunch of different segments. So I can look at the back end or the front end. Now, my servers or my application itself, a lot of what we do in New Relic around APM would be centered around back end. So you notice in the red diagram markers here, I'm looking at the back end times, and that should most likely take about 20% of the time. So 1 second there, and then the front end takes about 4 seconds. So that's traditionally what we see. when you hear the 5 seconds is what our page took, that's all the way at the end, at the load event end. So I have in a sort of a red marker here. This is how we measure today the onload of the page complete. Now, the beauty of the navigation timing API is if for some reason tomorrow we start reporting that we're at 6 seconds, I need to know where I lost that 1 second. So again, the strength of the navigation timing API is the fact that I have a lot of different markers now where I can figure out where that 1 second was lost. Did it happen somewhere in the processing section between DOM content load and DOM content complete, or the DOM complete itself? If it is, then I can figure out which assets, JS, CSS files, etc., are being processed during that time, and perhaps I can root cause and figure out why we're getting slower. So we're not saying that the navigation timing API is something that you shouldn't use. We actually believe it's strongly that you should use it. However, the final page load itself can be a little suspect. So why? 15 years ago, basically around the time when they started drumming up the navigation timing API, pages were a lot simpler, right? When the page was fully loaded, perceived equals pretty much the onload event. The other reason, again, that we use this a lot is because it's pretty standard across all browsers, right? So it's an apples to apples comparison of when something starts loading, DOM processing on IE versus Chrome versus Safari, right? So the final thing, again, is that it's lightweight, right? All of this data, all of these marks and measures that are inside of the navigation timing API already exist in the browser. So it's not really a lot of work for us to get it, right? A small JavaScript snippet can be laid onto the page, and we can just collect the data and send it off somewhere, right? And that's where New Relic becomes involved. We collect it and then send it off to our analytics engine. So this is kind of, again, what we're doing today. The onload is basically the page complete. But we can do better, right? So from a performance perspective, a lot of what the market is switching to is perception, right? So what a user feels the page from that speed perspective, that matters a lot more today than what the API says, okay? So from a perspective of user behavior, driving user behavior, one of the main reasons we're all here again is if we can make the experience better, customers will actually stay on my site longer, or they may purchase something. And that's really what we're getting down to. So if we're trying to measure their experience on our site, we need to start thinking about their perception of it as opposed to sort of an outdated API. I mean, again, I'll call it like I see it from that standpoint. But what we know is that the rendering times do not necessarily equate to that onload. There's a lot of dynamic content, Ajax, CSS, there's a lot of new inventions that have happened over even just the last 5 years. Also third-party assets. I have a lot of clients that I sit down with and they go, I know my pages are fast. That time that you give me, I know that's not my real time. We have all these ads and services. That's true also, right? There are third-party assets that load up slow, but one thing to keep in mind is that your name is on the website, right? It's your brand reputation. And the client doesn't necessarily know that you have whatever it is from an ad service perspective. They're going to measure you by your page. So again, that may not necessarily have anything to do with the onload versus the perceived, but let's keep that in mind as we move through this, that the perceived time might not line up with that. So is it faster or is it slower? That's actually a good question. If you notice on the bottom of the slide, the last few bullets, sometimes the onload actually fires way later than the render. I see this more often than not. This is if I had to split it up, I see this most of the time. So what it's telling us is that our page is slow, but in reality, it's actually not that slow. So here's an example. If you look off towards the left-hand side, we have a screen. I'll be showing this to you live in a demo, how I actually found these 1.9 versus 4 seconds, but 90% of this page is rendered. There's really not much else going on, maybe below the fold, maybe off screen, but it takes about 1.9 seconds. Whereas the analytics engines are reporting to me that things are taking 4 seconds. So my onload is telling me that my page is much slower than it really is. That's one example. The other example is a little bit harder to find on sites, but it's actually a little more dangerous. It's where you're being told that your page is fast, and in reality, it's actually a lot slower than that. Now, sometimes that only may be a couple of milliseconds, right? So it may not be a big deal, but it's still important for you to know whether the perceived performance is happening before or after that onload event. So with Gmail, for example, if you've ever opened up Gmail and you see the loading screen, everything else looks fine, except you're just waiting for all the emails to populate, the onload is already fired off. So basically, they're reporting that the page is done, but you're not done from a user experience because you're still waiting for emails to populate. Now, I'm not going to show you that example. I have another site that I can show you, but in that example, if I were to do that, you'd see all my email. So we'll pick another site, and I'll show you another one where the onload fires off a little too fast, right? Finally, before we get into some of this, again, business impact. One of the things that's really interesting over the last, let's say, 8 years, I spent a lot of time just trying to prove, like basically up on a soapbox trying to prove that performance mattered, right? And the way we proved that performance mattered was with a lot of these case studies showing me, if I was to just shave off 100 milliseconds, like the Amazon report, I actually could either reduce the amount of drop-off I have on my site, or bounce, or abandonment. In this situation, again, 100 milliseconds of latency or slowdown equates for them to about 1% drop in sales, right? So Walmart came out with another study as well that showed the opposite effect, where it's, again, I can increase my conversion rates, right, if I just improve my performance by a little bit. So these are the promises that we have, right? These are the things that people tell us. If we do this, I'm going to get some gain out of it. So great. Here's sort of my point, though. So my spin on it is there is sort of a big difference whether I'm using the onload or a perceived time when I do this kind of a study. And so you might not hear this talk track too often, but we have a huge risk that I've seen in the marketplace where you spend a lot of dev effort, or hundreds of thousands of dollars making these pages faster and monitoring it, and you don't see the uplift, right? So here's the example. Let's say the onload's coming in at 4 seconds, but my user perceives it in about 4, and I make a bunch of improvements, and now my onload's at 4 seconds, but I'm not seeing my 1% or 2% or even more of what I'm supposed to be seeing. Then this is a danger, right? This happens. I have seen this happen in the marketplace before, or in a client account. And the reason really was because of the fact that the user didn't really perceive anything different, right? So have I truly made the experience better for my end user? And the answer was no, right? If the user still feels like the page is 4 seconds after all of your changes, it would be silly of me to sort of expect, change in behavior from them. It's still pretty much the same to them visually. And that's really where we're going to get into the demo. I can say this stuff, but I'd rather prove it to you and show you on a few sites how this works. One of the other things that's nice about it is after you're done watching this, you'll be able to do this on your site, on any page you want to, within 5 minutes. So what we're going to do is we're going to do a little demo using Google Dev Toolbar. I'm going to show you actually our own new Relic site. And before we get started, I want you to sort of watch as I do this and think to yourself, when is this page loaded? When do I think it is? And then as I show you what the time really is from an onload, I want you to think how much different that was. And then finally, let's start thinking about other things besides just that perceived. What are ways for us to transition into how to measure this a little bit better? So I'm going to jump over into Chrome, and I'm in on incognito mode. One of the reasons I do this is for caching. So I'm not necessarily caching the page, but let's just go to newrelic.com, and I'm on the home page. And so what I want to go over to is one of our customer pages. Why do our customers love us, right? And we have a lot of business cases and examples on here, MLB. So we have our customers' logos here. And for me, from a performance perspective, I want to make sure that those look good and they basically come up quickly, because it's not just our reputation, but it's our customer's reputation that's on our page as well. So how fast does this page take to load? When you saw me load it up really quickly, it was pretty quick, but pretty quick is not necessarily a good metric from, basically I'm not going to report it's pretty quick to my boss, right? So let's get a little bit better here. Right click and inspect. And now I open up a bunch of code. So anybody who doesn't like all this code on screen, don't worry. We're going to move away from this very quickly. There's a performance tab. It's very simple. You click on the performance tab, and what I'm going to do is refresh the page, and it's going to tell me how fast this thing is loading, right? I'm going to get some JavaScript profiling that happens. one thing I want to do right now is I'm going to just slow this down artificially, right? I'm on corporate network right now, so I'm very fast. I'm on a corporate laptop that has been given to me, so it's also very fast. This may not necessarily represent the experience of an end user that's coming from their home or from, a slower area from that standpoint. So just to basically slow it down a little bit, I'll do a before and after. We'll do one without the slowdown, but let's just slow it down a little bit. That way we can sort of time this a bit. And what I'm going to do is just drop this off screen a little bit. And then I'm going to show you a super secret technique that I've learned over 16 years of doing performance. We're going to refresh this, and then once you start seeing white screen, we'll start. Okay, so here we go. 1 alligator, 2 alligator, 3 alligator, 4 alligator, 5 alligator, 6 alligator. Whoop, there we go. And that's when I feel that it's perceived. So some of you might be getting a little chuckle if you ever played sort of flag football or ever counted. Some people count Mississippi, some people just say 1/1000, but if you use a word like that, it usually gives you that extra timing so that you get the seconds right. So again, if you told me, Ed, what, in your professional opinion, how fast does my page take to load? I'd have to go with about, I don't know, 6 to 7 alligators, basically. And we might laugh, but at the end of the day, at my perception there is going to be way more spot on with my, rudimentary ways of measurements than what the onload is. And that's really what I'm trying to do here, right? It's like, okay, it's not really a joke, but at the same time, if I can actually time it better in alligators than the API is, maybe it will get people to sort of open their eyes a little bit about what's really going on. So what I'm looking at is a bunch of colors on screen. Let's focus on the top. I'll zoom in to show you what I'm going to be looking at. These little white spaces here, that's the page as it's starting to render, right? So I'll zoom in a little bit further just to sort of see it. But as I scroll over, you'll start to see that the MLB page starts to load for me. So let me zoom out a bit. Now I'm looking at a timeline. What happened during these, 6 or 7 seconds, whatever it might have been. At 1 second, I'm still at blank screen. 2 second blank screen. 3 second blank screen. What's this little like yellow markers? I'm seeing these yellow markers, green markers. This is what becomes very interesting. Now this FMP, this is sort of the first meaningful paint that happens on screen. So a lot of people in the industry have said, yeah, I want to measure time to first paint. I can't tell you how many times I have people come to me and say, Ed, how does New Relic measure time to first paint? And I go, I can get that number for you, but are you sure it's going to be meaningful? Because technically I'm looking at white screen, even at the second candidate for the first meaningful paint, right? I'm still looking at white screen. So that's kind of one thing to keep in mind is time to first paint, your mileage is going to vary, but a lot of times it's going to be a blank screen. The other one I hear a lot of people asking me about is the DOM complete, right? Or the DOM content loaded. When my DOM content's loaded, I'm pretty, accurate that my page is loaded. So let's just do that. Do that with a grain of salt, right? Your page will be loaded a lot more than the first paint, but it doesn't necessarily mean that it's completely loaded. So that's what we're seeing here, 4.76 seconds. As I scroll over though, now what I'm looking at is, boom, at 6.25 seconds or so, I'm 250 milliseconds off using my rudimentary alligator technique here. And that's pretty accurate. So I said it was, between 6 and 7, probably about 6.5. I think that's what I said. So that's when I'm seeing it right there where it says MLB loves us and you will too. That's my perceived load time. What if I could set a mark right here and I can measure that with every user that comes in? Because what's the alternative? What's the danger? What are we doing today? We're using the onload event. And as I scroll out, the onload is this red dot. So 6.25 seconds is what we're saying perceived load time is. But the onload is 13.48 seconds. So when I look at my analytics tools, that experience that you just saw was 13.4 seconds. So when somebody comes to you and says, my pages are really slow, I need to, first off, if I'm the manager and you're reporting to me 13-second page time, I'm firing off alarm bells, excuse me. And I'm saying, we need to get this under, 8 seconds. Well, technically it's already under 8 seconds, right? So this is the danger, and this is what I'm trying to prove to you. Just so that everybody doesn't think our page is really slow, let's try it again very quickly. And not to take up too much time, but let's just refresh it with no throttling. 1/1000, 2/1000, 2 seconds. That's good. It's a little over 2 seconds. Maybe it's a little under 2 seconds. And that's my customer experience. That's what I feel. So in a normal case, if I'm coming in, I'm thinking, 2 seconds. Let's see how accurate we are. It's under 2 seconds, right? So not as accurate with the thousands. Maybe I should have stuck with the alligators. But we're looking at close to 2 seconds, 1.75. You can zoom in and figure out exactly what that is, right? About 1.75. But still, that's when we're perceiving the load time is complete, as opposed to the onload event, which is way out here at, closer to 3 seconds. So that's kind of the danger here. This is the numbers that we're reporting. These are the numbers that you're actually seeing in Google Analytics, browser, any other RUM product that's out there. So let's switch gears. Let's think about another one. Hopefully we've made the case that the pages are actually meaningfully painting or feeling from perceived perspective much faster than they really are. What about the opposite case? So let's go to apple.com. They actually have a very fast page that comes up. And so it's going to be one of these examples where their onload actually fires a little bit differently, right? So as we come in here, you'll notice that it's very quick. So let's just throttle this again, just so we do this repetition standpoint. We're throttling it, and we're going to basically start running it. And we're looking at, again, maybe 2 seconds, very quick for my time to come up. But one of the things I like to use on the Apple example is there's tons of things to measure, right? At a half a second or so, I see the white screen, and then all of a sudden I see a banner. So let me zoom in. You see that little banner that has the Apple? Oh, is it not zooming in? Okay, sorry, I'm not sure if the zooming's working or if it's just on my screen. I'm looking at another console that shows me what you're seeing, and it doesn't look like the zooming's happening for some reason with GoToWebinar, but you can see that the banner jumps up on the top of the screen here, and then a little bit later, the hero image or the splash image starts to come up. And then after that, you'll notice on the bottom, text, right? Text wasn't there, text is there. So I have 3 things to meaningfully measure. If I'm Apple, I'm like, okay, I want to know how fast it takes before my banner comes up. I want to know how fast it takes before my splash screen comes up or my hero image. And I want to know how long to the first text. Those are 3 good ways to measure as opposed to the onload. But in the onload, I mean, what we're seeing here is that the onload is taking, in this red, it's happening well before my screen is coming up, right? So again, how does this look while it's happening off screen? You just hit refresh. You have your slowdown, and it will go out and profile and take a look at it, and you'll see the onload happens before, whether it's a lot more or whether it's way before. Here's another good example of not using DOM content loaded as an equation for that the page is done. In Apple's case, if I use this number, it would be basically still white screens except for just the banner on top. So with that, let's just to make sure that nobody thinks I'm picking on Apple because they're firing off an onload early, let's look at what happens with their site when there's no throttling whatsoever. It's extremely fast. So if anybody's out there trying to figure out ways to make their pages faster, you may want to go and inspect the way that Apple builds pages, because this is quite fast. And again, even on the fast part right here, we're double almost. I'm looking at onload events in the 400 millisecond range, but perceived performance closer to 800 milliseconds. So again, let's move on. I think you guys understand what we're getting at here is that, again, we're trying to prove that perceived performance is very different than the onload, right? So our key takeaways, let's remember, did the page feel, how long did it take? That's what your user thinks about when they're hitting your page. They do not think about that extra 7 or 8 seconds that was going on before the onload fired off in our first example. And then other things I talked about is which other areas should I time? That leads us into a very good discussion, and I showed 3 examples on the Apple page, but here's some other examples that the industry uses. And so sometimes these will be thrown around and we'll show you. So one example is a hero image, right? So that hero image, if you'll notice in the middle of the screen, this splash ad that's coming back in the background, how long does it take before somebody sees that? A lot of times that is one of the best indicators that I see in the market right now with whether somebody believes that's true. So for e-commerce sites, right, if I'm trying to buy a pair of jeans and I see the jeans come up on screen, I'm usually feeling pretty good that this page is ready to go, right? Most likely the text is there, but that's in the third bullet, the time to the text. How long does it take before that text comes up? I see that a lot as a secondary measurement that people are doing. But that hero image is called a hero image for a reason. In the comic books, when the hero shows up, the day is saved, right? So it's the same thing with your pages. There's, a little bit of trepidation as your page starts to load, and as soon as it comes up, if it happens fast, I'm feeling good about the site. If it happens really slowly, I may or may not necessarily want to pull my credit card out during this experience, right? That's kind of the reality that we have here to face. So what does Netflix do? Netflix, they definitely use, well, they use a lot of different things, but one thing that they do focus on as well is DOM Interactive. That DOM Interactive, though, again, as I showed, you have to test it, right? They built their page specifically to fire off at that time when it happens. So they can use the navigation timing at any point that they want to. If you want to build your site to the code and the spec of the navigation timing API, then you can use all those markers and feel pretty confident about them. But again, like I say, test it first, make sure it's not just white screens and you're not just reporting something way faster than you really should be. Above the fold is another thing that people have been trying to get to. If you'll notice on the left-hand side, it's basically everything that's viewable. The difficulty here is screen size can definitely cause some issues, that what somebody sees above the fold on a different screen size, depending on how you build your page, right? There are ways with dynamic content load and better unique design to be able to get them all to fire off in the same way. But it's not a measurement that everybody can do, and it's going to change from site to site, and it may change from page to page. So keep that in mind before you just say, hey, how do I do above the fold? That's a conversation. It's not just an easy metric to come up with. Time to first interact, that's another one that's very interesting that's starting to come up. When does somebody actually start scrolling on my page? When do they start clicking? When are they mousing over? Facebook uses this as well. And then I think one of the things that Clay's going to show you is the CSS and JS blocking. I think this one's important more for the devs, because if you have a JS that you find is starting to slow things down and you're trying to do root cause analysis or you're trying to fix it and make it better, you can use some of these best practices to just mark, when is my JS done blocking? And then you can start measuring that as you make improvements. So how do you know that it's getting better? Well, it's getting better because I'm measuring it and I'm marking it. And every user that's coming in over the next 2 weeks or week, I'm seeing it get better. So with that, I think let's jump into some of the code, and we'll let Clay take you into how to actually script some of this.
Great, thanks very much, Ed. Ed just described several different ways where we can actually measure perceived performance. I'm going to jump into the product itself and actually show you what that looks like in New Relic and how to get started doing that. Just to kind of give you some context right off the bat of how are we actually collecting these measurements? How do we actually collect the navigation timing information that Ed was talking about earlier? We use a product called New Relic Browser. And how Browser works is it's very straightforward for anyone that's ever created a web application before. It's just some code that you run that's non-blocking. You put in the head of every single one of your pages. It'll actually start to collect some of those key metrics. And in addition to collecting those navigation timing metrics, it actually has a couple different APIs. So then we can add some very lightweight custom instrumentation to start measuring perceived performance in different ways. And once we're actually collecting those measurements, we can then see it in the Relic Browser and Insights and kind of go from there and make those, kind of do that analysis of figuring out, well, what is perceived performance? And also what are the trends in perceived performance over a longer period of time? And there's more to Browser than just kind of this custom API where you can actually start instrumenting to get those perceived performance metrics. It also captures obviously all the standard W3C navigation timing metrics, but also errors as well. And we'll briefly go into that, but for the purposes of this webinar, we're really focusing on the perceived performance case. So just to jump directly into the code, and if you're not super deep into front-end code or JavaScript or HTML, I think it's still pretty straightforward to follow along. It's pretty lightweight, and you'll see that there's really not that much involved. It's not a multiple-hour project. But to kind of demonstrate this, I've created a really simple example. It's in this publicly facing tool called CodePin. You can actually see the URL here if you actually want to see it and kind of poke around in the code. You're more than welcome to. And if you're interested, we can also send this link out to you as well. But I've created a very boring kind of example page, but one that's simple, so it's kind of easy to show where we inject the measurements to see perceived performance. Just the construction of the page before I jump into the HTML itself is we've got a header, we've got a large banner image. We can think of this as the hero image. Then we've got a subheader and 2 other images as well. And so we're actually going to use this as kind of our sandbox or test bed to inject those perceived performance measurements in there. And then from that, we're going to actually jump back into New Relic Browser and see what that actually looks like and see if we can get any insights from that. So I have the CodePin page. If I open up edit mode here, we can actually see the source. Right here is the HTML source. So just to kind of briefly walk you through what's going on here. It's not visible, but we do have one blocking JavaScript. It's loading jQuery. This is very common. We're not using the script async attribute. So this means that the time it takes for the browser to actually load this and parse it will block the content below it. And because of that, we can actually use that in an inline script snippet here to actually mark that when it runs, we know that script directly above it is done blocking. So that's our kind of first measurement we're going to do. We're using the W3C user timing API, which is just performance mark. And I've written a custom wrapper around it to actually send those events to New Relic whenever these are getting called. And I think that's generally a very good best practice. When you're kind of doing this custom instrumentation, it's a really good idea just to have a function, some sort of convenience function that allows you to call these using the same, kind of the same function call. That obviously has benefits of just centralizing that code and making it easy to maintain, but it also makes it easy to document to other people in your team kind of what you're doing and what's actually going on. And I'll jump into kind of our wrapper code next and the individual New Relic calls, but I'll go ahead and go through the other kind of perceived performance measurements. So this is the very developer specific one of we want to know when this jQuery JavaScript code is done loading. That's the first one. Back on the page itself, we have the header title, just some more ipsum here. But you see right here, it's loading a 500 by 150 placeholder image. And we're using the onload attribute of the image tag to also call performance mark. And then a really nice thing about this is that means that we know when this image loads, we're going to call back into JavaScript and mark header loaded. And the strings in these events are all custom, obviously following a consistent convention across your entire site is highly recommended. Here we're just using pretty straightforward camel case strings that match pretty closely to what's actually happening when this page renders. So far, we've tracked when this 500 by 150 image loads, and we've also tracked, obviously it's not visible, when that jQuery script is finished downloading and parsing and it's been loaded in the page. Scrolling down, you see right here in this small viewport, we're more or less around where we would call the fold, the content that's visible above the browser fold and below. We'll call the fold right after the 500 by 150 image, but right before the smaller text. So again, the general technique, and we're using best practices from the W3C itself here, but we have an inline script block, and again, we're using performance mark to just kind of annotate the page itself, and we're going to call this one above fold complete. Obviously, the fold varies depending on the page, but it's a really nice thing to measure because it allows you to say that we know or we're pretty sure that the content visible to most people has been loaded. And we're using that right here on line 22. So far we have the script, this 500 by 150 image, and the fold itself. The last one we want to measure is just additional images. So we have 2 more images down here as we saw on the page before. We have one smaller 150 by 150 placeholder image, another 350 by 150 image. We could imagine that these might be kind of in an e-commerce context, maybe specific product images or specific actions that you would want the user to take. So if this 150 by 150 image was a buy now button or something that you know is going to be important for the overall flow or the expected flow of the page, it's pretty interesting to kind of measure that. So again, we're using performance mark, and we've given them 2 unique names so that we can actually see them when we look at them in New Relic Insights, image loaded 1 and image loaded 2. So we've kind of, we've measured these 4 different events: the scripts, the above the folds, the kind of main banner or hero image, and these 2 smaller images. What's actually going on when we call that performance mark, using some custom JavaScript code, I'll go over very briefly, is 2 calls to New Relic's JavaScript agent. When you have New Relic's agents loaded in the page, it exposes this object, a JavaScript object called, not surprisingly, New Relic. And there are 2 really interesting function calls that allow you to kind of create these performance measurements and annotate them. And this is done automatically using our wrapper that hooks into performance mark. But just briefly, this is what we've seen in the documentation. We're using set custom attribute to actually see the timing in Insights, which is our dashboard tool. That also allows us to create custom alerts. So say one of these attributes was important and we wanted to be alerted if the performance suddenly degraded, or if it went up significantly, maybe after a bad deploy, or a third-party script started misbehaving. And the second is add to trace. And I'll show this very shortly, but add to trace allows us to actually see that event in the browser waterfall, similar to the Chrome developer tools, but in New Relic itself. So it's collecting those navigation timings, the navigation timing information, and how resources are loading, and building a waterfall of what that user was experiencing when they loaded in the browser. And then we're going to be able to later see that in the product. So between all those 4 things, we've marked it, and we have a little, we have just some pretty straightforward wrapper code that we're happy to share if you'd like to see it. But it's just a convenience method that, again, calls New Relic set custom attribute and New Relic add to trace. So whenever we call performance mark, we get 2 different types of measurements in the New Relic product itself. And it's pretty brief. It's even maybe a little bit too long because I've added some safety checks just out of caution, but all in all, less than 50 lines of code. So we've added that, and after we've added that, what that means is whenever anyone that, well, I guess JavaScript does need to be enabled, whenever a user, including myself on this CodePin, actually interacts with the page or loads it, it's going to actually start gathering those metrics. And from there, we can do some pretty interesting analysis on what's actually happening. So I'm going to jump over to New Relic itself. This is our browser product, and you'll see the app name is CodePin W3C Polyfill. That's the name of the front-end application that we were just looking at in CodePin. So that New Relic JavaScript agent, which I've loaded in the head, which wasn't visible, it was off the screen, that uniquely identifies that code on that page to this application name in New Relic. And as you can see here, this is the main overview page. You pretty much see the navigation timing metrics you'd expect to see. How much time is spent in the network, how much time is spent processing the DOM, and how much time is spent page rendering. And to Ed's point earlier, this is all still really useful information. We think navigation timing does expose very actionable insights and metrics to people. But again, because we've added that custom instrumentation and just a couple lines of code, around 4 in total, just using inline script blocks, we're able to get a little bit deeper. So one thing I want to go into first is the trace itself. So we can think of this data having 2 very broad different types. The first is metrics. Metrics, like the ones you see here, are really useful for understanding trends over time. But traces, much like the information you saw in the Chrome developer tools, really help us understand and go a little bit deeper on what was the chain of interactions, what are the chain of requests that actually took place when an individual user interacted with the page. And you can get to that using session traces right here. Because I'm on a little bit slower Wi-Fi than Ed, I've already loaded it in this tab right here. But we're going to go ahead and go into session trace, and you see right here, it looks somewhat similar to the Chrome developer tools network request waterfall. There's a couple important things to call out. First of all, you see every single asset that was requested. Here we see the jQuery file that was loaded, and we quickly see all of the placeholder images also load. Alongside that, we also see all of the W3C navigation timing events. Navigation start, that's a fairly large diagram that Ed showed at the beginning of the webinar. We see all those events, but importantly, we also see all of these custom events we added as well. Scripts done blocking, so we know that that was the event we added immediately after we loaded the jQuery JavaScript file there. And you see here on the timeline below, that took a couple hundred milliseconds. If we scroll a little bit farther down, you then see all of these events. So we're actually loading the image right here. We know it's not actually completely loaded and rendered until a little bit of time later. So header loaded, image loaded 1, image loaded 2. And then finally, the load event end. So we have a really interesting trace of all the events all the events that happened, including our own events, when this page was loaded in Mac Chrome, which most likely was my own page here. And from there, we get a really interesting view that's useful for debugging of understanding what were the sequence of events and where are my custom events, and using that to really understand what happened. Traces are very useful for kind of one-off debugging and understanding what happened. But I think the really interesting thing is understanding those custom metrics in aggregate. And from there, we're going to go into New Relic Insights, where we can actually see these in a dashboard. So this was the add custom attribute call that allows this data to be available. And immediately here, let me just move the screen over slightly. You see all of these custom metrics that were loaded, and these are in aggregate over the past 24 hours. So we see what was the average above the fold time. This is in seconds, around 500 milliseconds. Onload average 600 milliseconds. Onload median a little bit less than that, and above the fold 480 milliseconds or so. So just like in Ed's early examples, we see there's a little bit of a difference, even in this extremely simple page, between what the onload time was and what the above the fold time was. In this case, much like a lot of the examples, onload is actually greater by around 200 milliseconds. And this is, again, just a very simple, somewhat contrived example, but there is that difference. And it's immediately noticeable, and we can actually see it over the past 24 hours. The other thing I want to call out too is because we're collecting this data from real users. So this is, the agent code is running in real user browsers, and those browsers could be anywhere in the world. We know from that browser metadata, specifically the IP address, and doing a reverse lookup, where that was. So particularly if you have a national audience, or if you're using a CDN, or if you care or want to track the user experience on a national or international scale, it's super easy here to actually facet all of those custom metrics by location. We see here that there's a big difference in Tokyo than there is in San Jose. I'm guessing that's not too surprising because I believe CodePin is hosted in the Western United States. So kind of getting that insight, and again, you can even roll it up to country instead of city here. We've done it from the US, Great Britain, Japan, and Canada as well. But getting to that is pretty straightforward, and can actually lead to some really interesting insights. Averages are useful. All of this data is also available through different percentiles. If you want to look at outliers or understand the overall distribution of these custom attributes, it's really straightforward. All of this is also backed by NERCL, which is just a query language. So if you want to customize these dashboard widgets or explore them a different way, you just click here, view the query, and you can run it and edit it in a SQL-like language and add it to a different dashboard as well. So let's say we wanted to look at the 95th percentile. We can just do that, 55th, run it again, and then we'll see the new percentile, which actually in some cases looks like is over 1 second, which is kind of interesting. So we've kind of gone through this example of, we've got the code, we have the instrumentation, we have the New Relic browser that's collecting this data. But more importantly, We have the ability to see it in the trace, so we can get down fairly deep into what happened for an individual user session, but also in aggregate and faceted by geography, and we can look at different percentiles and even see it by different URL, browser, and operating system as well. So all of that metadata that's being collected with these custom attributes can also be faceted. We're running a little bit short on time, but I just wanted to briefly mention one other kind of really nice thing that this data enables, and that's consolidated alerting from those custom attributes. So we have all this data, we're collecting on it. Some of our customers put this on a large kind of TV kiosk or screen. Another way to kind of get alerted when something goes bad versus constantly looking at it and logging in is just defining an alert. So we saw earlier how all of these kind of widgets on the dashboard are backed by a query language. We can actually create alert conditions based on that as well. So I'm going to jump over to New Relic Alerts, and you actually it's very straightforward. If you have a widget, a dashboard widget you like, you more or less just copy and paste that, and you create a new NERCL query alert policy, and you can even test it out. So right here, we're saying, above folds, if the average above fold complete, and this is very similar to SQL, if we've collected that and the duration is greater than 1.2 seconds for more than 5 minutes, I want to be emailed, I want to get a Slack or HipChat message or potentially a PagerDuty notification. And we can actually preview it before we create it. But you see this specific condition, if we do it for at least 5 minutes, in red here, we see all the violations. So in this case, it might be a little bit too noisy, but this is really useful to kind of have a sanity check in place and to move to a really proactive model where you can get alerted to very negative performance degradations based on perceived performance before users complain. And again, that's all rolled up in the same platform, so you can create policies based on multiple applications as well. This could be consolidated across different application names. So right here, the application name is just our example, but there's nothing to stop you from doing this for multiple apps. And if any of this is interesting or you have any questions, I know we have about 10 minutes and wanted to leave plenty of time for that, but feel free to use the questions panel, and we'll be happy to go into more detail of any of the features I just described. But on that note, I'm going to kind of head back to the presentation and turn it over to Ed to wrap up, and then we'll go into Q&A. Again, just use the questions panel and go to webinar, and we'll get to those shortly.
Perfect. Thanks, Clay. And I think really just one final slide before I know we have some questions coming in the queue right now, but just putting it all together again, what did we learn today? Performance matters. We truly believe this, but perceived performance matters more, right? That onload event may not necessarily be the best metric to report your page speed. Using that user timing API, it's really powerful. People have been trying to sort of adopt this for the last, I'd say, about 5 years. And I don't think it's happening fast enough. I think this is a really, truly powerful way for you to start measuring your own clients' perceived page loads when they believe it's complete. And I think if you're measuring what your clients are feeling, then your ability to use that information to help you make that experience better, or just to even know that the experience is not as good as what it should be, that's going to matter more for the client and for you when you start looking at how to make this better. Finally, again, New Relic Insights, it's a real-time engine, right? I mean, Clay showed you how you can pump the data over there. You can then facet it by city, by browser, and you have all of those metrics that you care about, not just in one place or with one session like I did with the refresh on the page, but from every client that hit that page. I can see it from their end user perspective. So we believe that that's going to lead into giving you a better understanding of that user experience. So what are we doing? We're collecting data. We're turning that data into insights, and really what we want is actionable intelligence, right? So let's turn that insight into action, and then let's drive business outcomes based on that information. So with that, I believe on the next slide, Clay, do you want a next slide? Thank you. We're going to open it up for questions.
Great. So we've had some good questions come in, and unfortunately, I don't think that we'll have time to get to all of them today, but As we mentioned in the beginning, if we don't get to them, we will follow up with you via email. So please feel free to ask it. If we can get to it today, we will. But if not, we'll follow up. So this is great. I appreciate you guys giving this presentation. Can you talk a little bit about like how does this work for single page applications, and does this work for React and Angular, for example? How does that work if I wanted to measure something like that?
Yeah, I'll go ahead and speak to that. It works very similar for a single page application. As you saw in the examples for the code, it's very minimal. Ultimately, the requirement for making this work and to measure it with any single page application framework is just to make sure you insert that script block and you mark that timing when that code is injected into the page. So for something highly dynamic, whether it's Angular, Angular 2, or React, it's just making sure that when that, say, React components or Angular component loads, you mark that and you measure that. But otherwise, the code and instrumentation itself is really lightweight, and getting that working, you just need to hook into the life cycle of the components managed by the single page app framework. But again, it's very straightforward, and it's very minimal. And arguably, I would say that this becomes even more important when you have single page app frameworks, because it's so highly dynamic, and maybe it kind of diverges even further from the traditional late 90s era web pages. Great.
So someone asked, like, yeah, this is great, but what's the impact of measuring this? Is it something that I can really put in production, or do I have to sort of do it in staging and then figure that out? How does that work?
Yeah, I can chime in on that one. Number one, because I have a huge QA background, so if anybody else is listening and hearing me answer this, I think it would be surprising if I said anything to the contrary. But you should 100% of the time test this in pre-prod and before you put it into dev. That being said, again, with that in mind, we are more than happy for you to test that out, because we are very confident that it's not going to impact performance. So what we've seen from the JS perspective for overhead is somewhere in the 15 milliseconds of overhead. I mean, if we had to put a number on it, right? If I had to stake reputation on how much overhead I've seen, 15 milliseconds, depending on what you're doing with it, that would come through from that standpoint. So I would imagine that 15 milliseconds is definitely worthwhile in order to collect the amount of data that you're getting. And then to one point that I've heard before, if we're splitting hairs on 15 milliseconds, then you must have an extremely fast page from that standpoint.
For sure. So just a few questions around the tools that you were showing earlier, Ed. On the Google profiling tool, the screenshots toggle, is that what shows the little thumbnails?
Oh, no, yeah, I think that from that standpoint, those screenshots will show up all the time, so you should just have them by default. But yeah, I think that there's a screenshot toggle on there. Sometimes it's a little more heavy, so it could slow things down inside of that toolbar, but I think you even noticed, even with the Apple's page, it was pretty accurate. But yeah, that should show up for you anytime. There's nothing you really have to do.
Great. And we have just time for a few more questions here. Thank you, everybody, for submitting them. With the demo that you had earlier, Ed, does performance profiling account for cached assets versus non-cached?
That's actually a really good question. That was one of the reasons why I popped into incognito mode. It was basically giving me a refresh that was uncached. So if you just do that same example in a sort of not incognito mode, you could do that for what it looks like for cached as well. So yeah, I would recommend doing both sides. It's a very good question.
So around the New Relic tools that were used, do you need both full versions of browsers and insights to use this? What New Relic tools were we showing in the demo?
That's a great question as well. So what we were showing in the demo was the browser agent is basically the JS snippet that collects all the information from that navigation timing API, and all of the marks that were being placed in there were done via the browser agent. So that was browser for sure. you're going to want to have a pro trial or version of browser to do that. The Insights piece, again, the Insights is not something that you necessarily have to purchase because it comes with 7 days of retention. Is 7 or 8? I could just in my brain all of a sudden. 7 or 8 days of retention is what comes with Insights with the browser product. So if you need to do week-to-week comparison, like this week versus last week, then you're going to need at least 2 weeks, and that would be something that you might have to purchase additional weeks or months of retention to do month-over-month analysis inside of Insights. So with Browser Pro, like if you turn a Browser Pro trial on right now, you could do everything we showed today.
Great. Sorry if we weren't able to get to your question. Please feel free to submit them if you have additional ones via the survey that will pop into your GoToWebinar panel after you close out. Or if you'd like to email us, you can do so webinars@newrelic.com, and we'll be happy to answer them if you have any follow-up questions. Just as a reminder, we do have FutureStack New York coming up, and that's going to be on September 13th and 14th in New York. So we have great speakers speaking there, like Malcolm Gladwell, Ray Wong, and of course our CEO Lou Cerny, who will go over some new launches that will be happening at that time. So thank you so much for attending. I want to be respectful of everybody's time, and again, we'll follow up via email if you didn't have your question answered here on the air. And again, if there are more, pressing issues that you have like to have answered, please feel free to ask them or let us know in the survey. Thank you, everybody, for attending, and I hope you have a good rest of your day.